of course it's a Django talk. What else would it be? So yeah, for those who don't know me, my name is Tom Eastman. I am a developer and open source technologist at Catalyst IT in Wellington. And I'm the only one from Wellington at Catalyst here today, but where are my colleagues? Where are my Australian colleagues? We got one over there, and I thought we had a couple others in here. Oh, well, come and talk to me if you want to work in Wellington. Come and talk to them if you want to work in Sydney or Melbourne. My expertise is in Python in general, and Django in particular. I've been working with Django for 8 years now. And this year, I'm actually doing something which is very similar to what I did at last year's pycon-au, where I gave 2 talks, and one of them was full of good ideas and best practices, and then the other one was full of really, really bad ideas and terrible things. So today is the one that is ostensibly good ideas, and tomorrow, if you come to my talk, you'll hear me explain how to delete your entire home directory with a single line of YAML or do a port scan with someone else's XML parser. So if you want to hear about some really bad ideas, come to tomorrow's talk. But today I'm here to talk about caching. And to talk about caching, you have to decide, well, that doesn't really narrow it down, does it? Has anyone here heard the saying that Eskimos have like 230 words for snow? Falling snow or ground snow or yellow snow or whatever. It's not actually true. Most people also know that it's not actually true. In fact, there's a Wikipedia page all about how not true it is. But it points to an interesting problem, which is when there are many different varieties of the same thing, a nomenclature tends to emerge so that you can differentiate between all the different varieties. In the tech industry, we seem to have the opposite problem when it comes to caching. We have one word, and it means everything. So how many different kinds of caching are there? So every time something ever is going slow, you try not to have to redo it, and so you make a cache. And so caching happens absolutely everywhere, in every piece of computing. And we use the same word for all of it. So you can have 2 people who know everything about caching, and they can try to talk to each other, and they just won't be able to communicate with each other. It's almost like being Perl developers. I didn't just say that. So what I'm trying to actually get through today is I want to give you a tour of the kinds of caching that you'll end up encountering as a web developer, starting with, well, so first of all, even just what I just said would take a semester. So I'm trying to give you a brief tour and some tricks that you can do. And if you already know all this stuff, then hopefully you're in a different talk. And if you're new to this stuff, I don't know, I'm going to try and cover a lot of material. So all I really want to do is have everyone here sort of come out of the room with one thing that they hadn't tried yet that they suddenly think, oh, maybe I should try that. And I'll post the slides when I'm done because the links at the end are actually the most important part of this, because everything that I'm talking about here has been explained better by someone else in a blog post or a tutorial somewhere else, and usually that person is Mark Nottingham. For those who know him, it turned out I was looking for material for this talk, and I found his caching tutorial, which covered everything I wanted to say, and suddenly I wasn't sure if I should bother giving it. But I'm giving it anyway, so that's the point. Here's a quick rundown of the sorts of things that I'm going to try and get through today. And I'm actually going to gloss over some of these and spend more time on basically the first one and the last 2. But when you're talking about web development, you're talking about the web browser's cache. Internet Explorer has a cache, Chrome has a cache, or you might be talking about the transparent proxy that always screws you up when you're trying to use your ISP. Or your company is hidden behind a squid cache or something like that. Or you're talking about content delivery networks. Or you're talking about reverse proxies like Varnish, as Simon was covering in the previous talk. Or you're talking about memcached or Redis, also as Simon was covering in the previous talk. All of this stuff just falls under the term caching. And then if we get through all that, I have a few bonus tricks that I want to talk about at the end. But we're going to actually spend most of our time on web browser caching because it's the part where you can get the most win for the least work. You just have to know a little bit more than maybe you were familiar with in terms of if you're new to web development, as I was when I started digging through this, you know that you're writing code that generates an HTML page. And that's not actually the whole story, because you're writing code that generates an HTTP response, and that's where you actually have more power than you thought you did. Everyone's familiar with clearing their cache on their web browser. It's about as common advice as have you tried turning it off or on again. But you want to be able to do more things with that cache. You want to be able to take advantage of it and use it smoothly and have it work for you than the other way around. So I'm going to cover just a couple of the things that HTTP gives you that HTML doesn't. And this is all stuff that is very easy to implement using any modern web framework once you know about it and want to take advantage of it. The key point is the browser cache actually isn't your enemy. It's not the thing that's preventing the guy using your site from getting the latest stuff from your page. It's trying to help. It's almost always trying to help. It's not always trying to help. I actually thought I had a good grasp on this stuff, and I was ready for this talk, and I thought I knew what I was talking about. And then an external tester for the project I've been working on came back and said, hey, absolutely nothing is working in IE. And I was like, okay. Catalyst is an open source shop. We use open source tools for everything, and we have IE and various Windows instances for testing, but we don't like using them. So we do all of our testing and development against browsers that work, and then we end up having to belatedly test our stuff against browsers people use. And there's a dichotomy there, which is no fun. So web browser caching, there's two concepts that matter. There's validation and there's freshness. And if you can get your head around both of these, and it took me a little while because I never actually called these by their names. Apparently this is the proper name, but if you get your head around these two concepts, then controlling the web browser cache becomes a lot simpler. Validation is, how does the browser ask the server if the version it has in its cache is still okay to use? If it doesn't have a way to ask that question, your web browser has no choice but to either guess and just use the page or image or whatever that it has in its cache, or grab the whole thing every time. Neither of which are ideal. One of them will hit your server too much, and the other one will just end up showing you the wrong stuff all the time. So what you need to be doing is always providing a way for the browser to say, hey, is this page still the version that I've got, without actually having to get the whole thing every time. Freshness is about cache control. It's about being able to tell the web browser, hey, you don't even need to ask me. You can use this image that you've got in your cache for the next 600 years. It's never going to change. Or the next minute, because this is a news website and we update it once a minute. So if you get a good grasp on these two things in the web browser and how to control them, your whole day goes a lot easier, and actually everything else just falls into place a lot better. You want to end up looking at something like this whenever a web browser hits your web page. Who knows what HTTP response 304 means? Cool, actually not that many. I was worried that I was going to be just talking to people who knew all this stuff back to front, and I was quite nervous about that. Who knows what HTTP 200 means? Who knows what 404 means? Right? Okay, so yeah, great. No, that's fantastic. So 404 is the one that you always see because you've gone to a thing that doesn't exist. 200 means you've got what you asked for. 304 means you don't need it because you've already got it. So what you're looking at here is a web page that is already stored in the cache on a web browser, and when it goes back to that page, it's asking the server, hey, do I need to get a new version of this image or this page? Do I need to get a new version of this JavaScript file? And the server is able to say, no, the one you've got is fine. 304 means it's not been modified since last time. You don't need to download it again. So all of these requests are super fast because none of them are a whole download. So this page is pretty heavy. It's got Angular. It's a megabyte or two. But that download, I can't read that. What does that say? Down at the bottom? 7.2 kilobytes. So once it's all preloaded, it's basically something that you can do at modem speeds. Now, to do that, you have to give the browser the means so that it can ask if the page has been updated. And there's two, I think only two, but there's two that matter. There's two fields in HTTP that you can control that have this information. One of them is the last modified field in HTTP. So with a site that's doing the right thing, when you receive, what did I pull? I pulled a comic from Imgur for this. I can't even remember what it was. Actually, it was something to do with Loki, because everything on Imgur has something to do with Loki. That image was last modified on the server on Thursday, the 31st of July, 2014. So that last modified header in the response headers, which is the bottom half, is stored in the cache along with the image, stored in the web browser's cache. Next time you go to that page, the web browser just has to ask. It adds, do I have a pointer? I do. So in the request, the next time, the browser can just say, hey, has this page been modified since this timestamp? And the server can look at that and go, no, it hasn't. I'll just return a 304 rather than sending them the whole 70 kilobyte or 700 kilobyte or 7 megabyte image. So 304, very tiny response, really quick back and forth. The trick is, so that is something that you pretty much get for free with any static web server, because every file on your web server, every image has a timestamp on it. It has a last modified date or a created date or whatever it is that file systems do with files. And Apache and Nginx and all of those just treat it right. They use, I think, I don't think you have to configure that. They just use that timestamp as the last modified, and if you stuck a new HTML file in there or a new image there, it would use it. But for a dynamic web page, you have to invent that timestamp yourself because, of course, you're generating the web page every time you hit your Django site. In Django, you have a mechanism to do this, which is implemented as a decorator that you would stick on your view. Now, I'm not going to go into too much detail about how to do this. I'm just going to explain that it is there because I kind of want you guys to rely on Katie Cunningham's advice from her keynote yesterday, which is the documentation isn't scary, and especially the Django documentation. I say this every time I give a talk. The Django documentation is the best piece of technical documentation on any project I've ever read. And you can learn so much about Django and HTTP and HTML and web development practices in general just by reading it. Are there any Django people here who can give me cookies for that plug? No. Russell ran away. But let's say you have your Django model and it has a timestamp, for example, like an auto-updated, what is it, auto now timestamp, which is updated every time you save the row. That's the sort of thing that could make a really appropriate last modified timestamp for your view, especially if you're talking in terms of standard Django stuff, like a detail view, where you have a page that corresponds to an object, and that object has a timestamp on it. You can use that timestamp as a last modified value, and that means that every time the person goes to that page, they'll be able to get the 304. Django will provide the 304 instead of making them download the page again. The timestamps can also be really useful if you have like a page that updates at midnight every day. You just need a date that you can use. In my project, I have a lot of API calls that provide lists of objects. So you'll have something that has like 1,000 objects in it. And the last modified timestamp is always just the most recent timestamp on any of those objects. And if you index that, then it's also really fast, or you can cache whatever the most recent value is. But the key point is Django gives you a decorator that adds that header, and then it will smartly return a 304 if the timestamp matches. And so that right there solves an awful lot of the problem and gives web browsers a cheat sheet that they can use to not have to download your site over and over again when it hits. If timestamps are difficult for you for whatever reason, and there could be a number of them, like access control rules or anything else, and you need a more flexible way of determining whether a page has changed or not, you have the other mechanism that HTTP provides, which is an Etag. Etags have the bonus that they're totally arbitrary. They're nothing to do with a timestamp. It's not if modified since. It's just, here is an opaque identifier, and it means whatever you wanted it to mean when you wrote it. And the web browser will ask, hey, last time I came here, I got given this Etag. Is this still the current one? And if it's not, then the web page will generate the whole response and return it. And if it is, then you'll get that 304. And the server doesn't have to do any work, and the browser doesn't have to do any work. And again, the Etag is completely arbitrary. It can be whatever you want it to be, which can be incredibly powerful and flexible. And Django gives you some of this completely for free. There's a setting, use Etags. And if you turn that on, then every single thing that your Django server outputs will have an Etag embedded. And that Etag is calculated by generating the whole response and doing an MD5 sum of the response to get a hexadecimal value, and that value is your Etag. So the downside of using that is that it doesn't save your server any work at all, because you'll go to a web page on your site and it will generate the whole response, then it'll calculate the MD5 sum of it, and that's when it'll notice that the Etag is the same as the one that the browser sent you and return the 304. So what you are saving is the download time. It'll do the whole response, and then it'll work out, oh, I don't need to send this response. The guy already has it. So if you want to be smarter than that and work out whether you need to bother generating the response before you can return a 304, you've got to write your own Etag function. And here's an example of a really, really complicated one. This is ripped straight out of my project, and I'm being a bit coy about what my project does because it's not been released yet, but it's a tool for schools and it's a tool for teachers, so that's why you see things like school ID in there and stuff like that. And you don't need to worry about too much of this stuff. All you need to really realize is in order to get my Etag for any page, I'm grabbing a bunch of information that I think is important, like what the query was, what the path was, the school ID of the person who happens to be logged in. That's important in the context of my project. I'm putting all this stuff into a dictionary, and then I am some arbitrary things from other views, details about their access control, and then I am turning that dictionary into a string, and then I am just MD5ing that string. Now, it looks like it's actually a fair amount of work, and it actually is a couple database queries, and it's not the cheapest function, but what it buys me is not having to generate the whole response, and the whole response could be a very large API call. Chris?
How do you guarantee the order of the dictionary keys?
I actually don't, and I probably ought to.
Yeah.
Sorry?
Hash randomization means they'll move around on every different process.
In practice, it actually generates hits fairly often, but it is a thing that I was grabbing this code out of it, and I was like, I wonder if I'm about to show them a thing with a bug. And I could well be. And so the answer to that is that code might have a bug, and I would do it by turning it into a set. Or an ordered dict. Either one would solve the problem perfectly. Ordered dicts, they don't, if you use REPR to represent them or convert to string, I think that they look a little different from a regular dictionary. So I would need to change the way I'm stringifying it. But yes, so this might not be, yeah, cool, thank you. This is crowdsourced debugging. But the point that I want to get across is the Etag function is completely arbitrary, and you can make it as complex as you want. And it gives you a lot more flexibility than just a timestamp. So with those two mechanisms, oh, and I haven't even shown you how to incorporate this into Django, but it's in the documentation there. It's another decorator. It's called Etag. It's really easy to find. And if you're interested in this stuff, read that documentation before you take my advice, because its advice is better, as you can see. But it works, and you end up not having to repeat work on the server when the web browsers, someone's just like hitting refresh a lot. So those are the two mechanisms that HTTP gives you for validation. I'm not sure if there's more, but those are the two that everybody uses. And if you start digging down deeper, you might get into things that a lot of web servers don't support, or maybe proxies don't support. That can end up happening. Etag support's pretty pervasive now, but it wasn't even as recently as 5 years ago, I think. So the second topic in browser validation and browser caching control is actually telling the browser how you want it to cache something. And that's defining a freshness value for it. And that means how long can I keep this thing in the cache before I need to either revalidate it or throw it away, or do I have to throw it away in the first place? And Simon also covered this in his talk. There's two mechanisms. There's the old school way, which is the expires header. And that one, Django doesn't actually give you a decorator to set this, I don't think, but Django's caching infrastructure, when you cache a page in Django, which we'll cover a bit later, does add this header. The timestamp literally just means you can keep this in the cache for until this time is up, and then you need to check with me if I have a new one to give you. And if it's a page that updates every day, you could set it to midnight. Or if it's a page that you really just want them to check every hour to make sure it hasn't updated, then you could set it to a minute later. Standard web browser configuration, Apache, for example, has a lot of, in mod expires, has a lot of pragmas which let you say, if it's an image, set the expires to a month after the access date. If it's JavaScript, set it to 10 minutes. You know, it's pretty arbitrary like that. And it doesn't cover a lot of circumstances. And so in HTTP 1.1, which is, how old is HTTP 1.1 now? 15 years? It's old. And people are still playing catch up and trying to implement it. Meanwhile, Mark Nottingham, again, is trying to invent HTTP 2. The cache control header was implemented in HTTP 1.1, and it has a lot more control, and it provides a lot more mechanisms for tuning how you want pages to be treated by caches, either at the web browser end or at the proxy end. And Django gives you a decorator that lets you arbitrarily set all of the individual options that this header provides you. And I'm only glossing over it here, but the key things that I want to point out are that max age is essentially the replacement for the expires value in the other header. So it supersedes it according to the protocol. And rather than being an arbitrary timestamp, it is, you know, the amount of time since you first downloaded it. So something set like this, public and max age 60, means, first of all, if you've got a squid proxy in the way of your web browser and the server, that squid proxy is totally invited to cache it on your behalf because it's a public resource. You'd stick private there if it was like a logged in thing that you didn't want the intermediary proxies to talk about. And keep it for a minute. And after a minute, you can still keep it, but you have to revalidate against the server. And then there's a bunch of other options like no cache and no store, and the distinction between those is a little weird, and browsers implement them differently, and that's where that IE10 thing happened that I didn't just tell you guys about because it was embarrassing. And so there's a lot of scope for tuning how a browser caches stuff here. And I recommend you read it. It's actually, I can't believe I'm going to say this, but the HTTP 1.1 spec on this stuff is actually kind of readable, and you should totally go and read it. I did all this stuff through trial and error, and I have a colleague who just is like, well, it's just in the RFC, because he's the sort of person who, he was starting on the Django project with me. He hadn't used Django before, and he was like, okay, I'll read the documentation tonight, and I'll be ready tomorrow. And he reads RFCs, and then he internalizes them, and then I ask him things, and he's like, why are you asking me? It's in the RFC. And he doesn't get that I'm asking him because it's in the RFC, and he's read it, and I don't want to. So the cache control header takes a little bit of trial and error just because web browsers and caches sometimes treat it a little bit differently. So those are the two header manipulating things that you can do to make life easier on your browser. What I want to cover next is the best practice for static files and for probably websites in general in modern times, if I can be opinionated, which I can because I'm standing here. every site has dynamic pages, be they generated by Django or generated by an API or Flask or whatever. And then they have their static assets, their JavaScript, their images, and all the usual style sheets and stuff that I can't write. I'm not very good at style sheets. And those things should be cached forever. You should never, ever expect a web browser or ask a web browser to download the same image twice. And what's cool is this has become fairly standard practice for big websites, but it was always kind of inaccessible for developers because actually making this happen took a lot of clever coding until someone came and did it for you, which is awesome. But static assets should have an expiry time on them of like 30 years. If you have an image embedded on your web page, once it's downloaded, it should stay in the browser cache forever, and it should never, ever have to even ask if it's been updated. And if that sounds weird, because of course you're changing your JavaScript all the time, and you're changing your style sheets all the time during development, you don't want to have to dump the cache every time, and you certainly can't ask your customers to reset the cache. You fix all that by changing the URL every time the file changes. And that also, immediately, like when you first see it, it sounds hard, and it would be if someone hadn't done it for you. So Django now, as of 1.3 or 1.4 or a couple releases ago now, has a static files app, which is where you generally handle your static files from. And it has a couple back-end storage mechanisms, and one of them is the cached static file storage. It almost looks like Java when you string all the words together like that. And what it does is when you run collect static and it copies all your static files into the place where you're hosting them from, it renames them at the same time. And it renames them to the file and then a chunk of mush right here, which is actually the hash of the file. Sorry. And it also, if you're using the right template tag in your templates, all of your links are automatically updated to that string as well. And because of that, you can have something in whatever piece of web server is hosting these files that looks something like this, where if your static file has a thing that looks like an MD5 sum in it, which happens to be, how long? 12 digits long. That's how long the Django one truncates the MD5 to. Set the expiry date to max. And max is actually, I think it's like the max of the big integer. It's like 2036. In any event, people aren't going to have to refresh their cache very often. And that's where a web page, after the first hit, suddenly becomes just insanely fast, because even if you hit refresh, it'll only revalidate. It won't have to download all the assets again. And if people keep coming back to your site, they never have to download the same file twice. And if you change that file, it'll change names, and they will get the next thing right away. So that's the best of all possible worlds, where if an update does happen, they'll see it right away. But if an update hasn't happened, it will never need to even ask the server, because the HTML that you've generated in your Django view covers all of that, because the file names that it's pointing to are going to change every time your code changes. Also, for bonus credit, if you're already doing this and you want to move forward, there's a third-party library called Django Pipeline, which does all this and more. It does a lot of cool stuff like minification of your JavaScript and compressing all your style sheets down into one style sheet. So if you're a perfectionist, you want to have a look at that as well, because it's awesome. So this is the biggest part of my talk, which is good because we're running low on time already. But that if you follow those rules, you can end up making your site really, really fast and approachable and cooperative with browser caches without a lot of work. That stuff kind of comes for free. Django Pipeline is a bit harder. Last Modified's kind of easy. Etags require a little bit of planning, but none of that is hard work, and the win is really quite profound. So on to the second circle of our quest down the inferno. Web caching proxies, and I'm really just glossing over this because I haven't had to deal too much with the intricacies of having to deal with someone's third-party cache, which is messing around with your stuff. Except for Telstra Clear are just being real, a word I shouldn't say because of code of conduct on my home internet connection, so we won't go there. But transparent proxies are not fun to have to deal with. Mark Nottingham again, this was in his caching tutorial. The key point is you have to live with them anyway. They're gonna be there. You can't get around them. That's not entirely true. You don't necessarily have to worry about them too much if your site is pure SSL. And that's one of the reasons why I haven't had to worry about them too much. My site's entirely behind SSL, and that usually means that the third-party proxies in the middle just pass it through, unless it's a man-in-the-middle proxy, which actually does happen in a lot of organizations. The bad news is in the old days, you didn't have a lot you could do to control their behavior. And the good news is that the cache control header is offering you some options for tuning the behavior of these caches. For example, this is the slide that you saw before, but it's got a couple extra options on it. Private might, I have to say might in all of these places. The proxy might cooperate with the private header and not cache it. The proxy might obey the proxy revalidate. It kind of depends on the version of the software they're using. But part of the point that I want to make about these sorts of proxies is that your work at the first level pays off. All that work you did about making validation quick and easy so that your site can just return 304s, and all that work of just working out on a per view or for your whole site, how long you can afford for something to be cached for on the browser, that stuff usually really helps when dealing with these proxies as well. And you'll find that they're a lot less painful when you're providing them what they need to know so that they don't have to guess and get it wrong and start delivering the wrong favicon when you've updated your branding. Chapter 4, reverse proxies. So I just went from circles to chapters, and if you're wondering about my Roman numeral there, it's kind of part of the point that it's not a bug, honest. It's part of the point that I'm trying to make about how people don't really follow the spec when they're implementing this stuff terribly well, or writing the slides for their talks. So reverse proxies are the proxies you do control, and they sit in front of your web server, or as, was it Simon last talk? Yep, was talking about, his was actually just behind the Nginx layer, but it's like the best computer science-y solution ever, which is if your server is slow, add another one. And that's pretty much all there is to it. If your website is slow and you want it to be faster, put a faster one in front, and maybe magic will happen. And actually, magic can happen. I'm going to gloss over this because Simon actually covered it really well in the previous talk, but Varnish has kind of become the standard reverse proxy for open source projects or a lot of projects in general. Varnish is a caching HTTP reverse proxy, and it is really, really fast. It's fast enough that the documentation says it's usually bound by the speed of the network. So if you have 70,000 connections to your server, it's probably just going to be fine with it. You'll just blow your modem out of the water or your switch or whatever. Varnish, in its most basic configuration, will forward requests to the server you specify and obey the cache control directives in the response. As Simon said, its default configuration is fairly conservative, and it won't necessarily cache a lot of stuff off the bat. But as he also demonstrated, and I'm not going to demonstrate here, but I'm just warning you, Varnish is a programming language and a technology stack in its own right. So it's a whole nother set of things that you need to learn if you're going to play with it. And it's a lot of fun to learn. No, sorry. It's the opposite. It's the other thing. I don't think he actually mentioned it, but the VCL, the Varnish configuration language, it is a language that is literally compiled into C and then compiled into machine code and stuck in the middle of Varnish. It's not a set of switches. It's not a set of configuration options. You write the code to, it's like a Mad Lib for a web server. It's a fast web server with gaps in it, and you write in the code that you want to happen in those gaps. Varnish and I have a bit of a love-hate relationship because I run it on a few sites, and I accidentally got into the habit of drinking Jägermeister while debugging Varnish, and the first time it was just coincidence, and the second time was enemy action, where I was my own enemy. But it is amazingly cool and fast, and you can do really cool stuff once you get the hang of it. This is the solution for, first of all, you have to control your own technology stack. If you don't have the ability to deploy Varnish, then obviously this isn't even an option. But if you do, and if you're in a situation where you have a page that renders slow, and it doesn't really matter, and you can cache it for a while, like stale data isn't critical, Varnish is something that you can put in front of it, and it just solves so many problems. Like, he mentioned just the 60-second cache for that Hacker News, spike of 10,000 hits. Something like that can really save your day. You can do anything with Varnish because, like I said, it's actually a programming language in its own right. That was just some stuff that I came off the top of my head. We have projects at Catalyst that you can talk to me or Andrew Bogue about later, which do some truly insane things with Varnish, like use it to load balance amongst multiple backends, which then generate the response and feed that response into RabbitMQ, which transmits that response to other cached areas in its own sort of impromptu CDN. I don't even know. This is not my... Some people at my company do strange things with technology, and they're scary. Finally, I want to talk about caching in the application itself, so where you're actually writing Django code and caching stuff to speed up your own responses. Django in particular, again, has an amazingly cool cache framework and wrappers around a lot of this, Redis or memcached, or it has its own local memory storage, and it presents the same API for all of them. And it gives you immense power and control over, well, just a set of tools that are really straightforward and clean to use. How you do caching within your app really does vary depending on the framework you're using. I am just sticking to Django, but these principles do apply to everything. Django has a quick switch which will cache your entire site. You set a few global variables, you add a few pieces of middleware, and as long as your site's largely public, this is a really good win. This is basically giving you Varnish without Varnish, because it's basically, if the page has been generated, keep it, and then don't bother generating it again for however long you've set that to, and just instantly tune down the amount of work that your server ever has to do. Caching on a per view basis is almost as easy. Again, add a decorator to your view, and it will cache it for the appropriate time. It'll set the appropriate expiry header so that the web browser also knows that if you hit refresh right away, you'd still get the same page. So it's not only caching it at the back end, but also providing the web browser the means to cache it further down the stack. I'm demonstrating how you use the decorator here and how you have to do it here. I really do like class-based views in Django, but this is not one of the reasons why. When you're trying to add decorators to class-based views, it's a nightmare. But the documentation makes it reasonably obvious what you have to do. It certainly doesn't explain why you have to jump through those hoops. Bonus trick. What if you want to have your cake and eat it too on your actual web pages as well as your static files, where you want it to be cached so that it's really quick to generate, but if the data changes, you want to instantly be able to refresh people's web browsers so that they're not stuck there, so that they're not stuck looking at a stale page. This was a trick that I invented, and I'm going to show you the code really briefly because Chris will find another bug in it, and I'd rather he did that outside of the talk. But here's the thing that I invented, well, that I came up with and then stumbled around and it fell over a bunch. But if your Etag is clever enough, you can use it as your caching key in memcached. So I added a lot of stuff to my Etag, as you saw in that code earlier, and then that hash that I get out of it, I can actually use as a key in my backend cache, so that if I can generate my Etag, so a browser will ask me for an Etag, and I will go, okay, that Etag is already in the cache. I can pull it out and return it right away. Or if the browser has never seen that Etag, if the browser's never been to that page and you go there, it doesn't ask, does this Etag match, because it's never seen it. But the first thing that my code does is it generates what the Etag would be for that page. And then rather than generating the response to that page, which again might be a 1 megabyte API call, it checks the cache first. And it can pull that out. That's turned out to be quite a useful little trick. And it's probably a perfect example of premature optimization, because I spent quite a while fiddling with this system before I actually had any reason to believe that the scale of this project would even need something that ridiculous. But I was having fun, and no one was checking up on what I was doing at the time. So I had kind of fun with it. And this is not really useful to show, but that's the code that's basically doing it. And it's not doing much more complicated than, my laptop is starting to freak out, but that's okay because I'm almost done. Do I still have a mouse pointer? I do. Let's see. Run your Etag function, get the key out of it, try and get that out of the cache. If you didn't get it out of the cache, then generate the response, stick it in the cache, and return it. Otherwise, just return it. So it's the same caching, it's the same sort of check the cache and return it, or generate it and return it, that you see everywhere else, including the Django documentation for the low-level caching API, which I've run out of time to cover. And it's just doing it using the Etag, which is a really useful sort of doubling of principles. Finally, the bonus trick, which is something that I really wanted to write in time for this talk, which is turning your views into celery tasks and returning the old result of the view while asynchronously running the view and storing it in your cache. And I thought that would be a really cool way to finish off the talk, but I ran out of time to write it. I'm running out of time to talk about it. And in the time that I had actually thought that this was a great idea, someone else went and did it. And I haven't tried this yet, but I'm going to because it looks awesome. And it's just decouple your views entirely from having to be run synchronously. And I think that that's probably about as brain-melty as you would want to get in this space. But I hope this works because it's something that I've wanted to do for ages. So we're finishing up. The lessons learned is we need more words for caching, because caching is, I've sat here and I've said the word caching like 800 times in the last 45 minutes, and we need better words. And the biggest win is just giving the web browser the right information, because that information also propagates up through the proxies on the way, and it caches, and it goes through, your front-end proxy. It'll make Varnish easier to configure if you decide to use Varnish. After that, what you decide to cache really does depend on where the slow points are. So this stuff, like the validation and the cache freshness stuff, you should always do this, probably just because it's good HTTP and it's good protocol. But then after that, what you cache really does depend on where the slow points are. And at that point, maybe you actually need to start measuring. Measurement is useful. And it can be a real pain in the butt to debug, but it's totally worth it. And I'm going to put these slides online because there's a lot of reading material that covers all this same stuff. You can get really good at it quite easily just by learning a little bit more than you already do. And I wish I had known these tutorials were here when I was beating my head against a brick wall trying to learn this stuff. Thank you so much.